Logarithm is a number of base must be raised to generate a desired number. For example, 2 to the x equals 508. Logarithm is that value of x. It's basically an exponent, that's all it is. Now it's on the next slide, but I don't remember how much you remember about the old log is base thing. But in this particular instance, x is a logarithm. Anybody know the base? Base 2, the base of the exponential function, whose argument would be what? 508. And that is the logarithm. It's close to 4.5. It's like 4.48 or something, I think. 8.47, I don't know. It's in that neighborhood. That's what a logarithm is. It's just an exponent value. Any questions on the definition of a logarithm? Moving on then. Your notes don't have that there, do they? It's written in red still, it didn't white it out or anything? That's how I had to learn them. Y equals log base A of x if and only if x is a to the y. And I don't teach it that way anymore. I use log as base. So the way you guys were taught, and I'll teach it again this year, is that a logarithm, base B, argument A equal to, E is an equal, okay, has an equivalent inverse of a base raised to that E, that base to that E, equal to the argument of logarithm. Oh, log is base. You remember doing that last year? Kelly said she didn't remember it being too hard. Or some kids just hate logarithms. Can't stand them. But that's what we'll be using in here, log is base. And what's probably up next in your notes is a couple of conversions. Change each exponential expression into an equivalent expression involving a logarithm. Now, the first example I do with you, I'll go through and I'll identify stuff. What's that 1.2 represent to you? It's a base. Why is it a base? Tell me how you know it's a base. Because it has an exponent. Bases have exponents. Speaking of that, what's that 3 represent to you? You can hear you. T. And the M on the other side of quality would be the argument or the answer. It's the answer of the exponential expression, which becomes the argument of the logarithm. Again, I'm going to write this down for you. Log is base. And Kelly, why don't you do the conversion? Convert that exponential function into the logarithm for us. You'll be victim number 1. You're reading that thing from right to left on this one. What's the base of log? Huh?
No. Oh, 1.2.
Keep going. Yeah. That's it. The conversion is 90% of the stuff. Even the conversion down logs are easy. Really, they are. So that was example A. Let's do example B. Aaliyah, can you convert example B for us? Argument. You either say answer or argument. It's not times 9. Because there's no multiplier. It is the argument of the logarithm. It is inside the logarithm. I don't know why I wrote a B. It's supposed to be an E, isn't it? Now, we're not going to leave that answer looking like that. Who remembers log base E, how you're supposed to write log base E? Oh, yeah, natural log. Natural log of 9. Any questions so far? Brilliant stuff. And the last one is for Miss Annika. Convert to C for us. Say base. Here's why. If you say log A, that's what you mean. Log A is a base of 10. You gotta say the base. You're not the only kid who's ever going to do that, obviously. But what's the base of this logarithm? Argument 4. 24, right? I haven't woke up yet either. What's that have to equal, Monica? 4. All right, any questions for those 3 individuals? Yes, ma'am. No. Log E is a special number. Or a natural number. That's natural logarithm. That's in a note somewhere. I'm just curious if anybody remember. We do talk about that. It's in those notes. ln is just a log of base E because E is a number. So that was conversion from exponential to logarithmic, probably the other way around, logarithmic into exponential. And I don't feel like doing all of these, but we'll probably do A and B. Go through and identify. When you read log, and this is how you read them. That's why I was getting on it. Log base A argument 4 equal to, and then there's an E in equal to, right? That's how you label the stuff. So when I walk through this thing, my base is A, my 4 is the argument of the logarithm, and the 5 sitting on the other side of the equality. The goal is to spell B, B-A-E. Now sometimes things are flipped around, you might actually spell E, but whatever, identify your 3 parts, and go with it. So if I was doing this logarithm, converting it into an exponential function, my base would be A, and there's nothing special about A. Its exponent would be the 5, and they would have to equal 4. Maybe the 5th is 4. Lord knows what A is. Porter, why don't you convert B into an exponential expression for us? Sounds good to me. E is negative third equals B. Anybody got any questions for Porter or myself? Good. Find the exact value of a logarithmic expression, and the goal here, and it's in your homework, if you look at it, there's a little section that says without the calculator. You're supposed to be trying to do it without a calculator. By hand. And to do these, you need to, the first thing you really got to be doing is asking yourself, what is the logarithm asking? You have to understand what the logarithm is asking. And what we'll do is we'll go through on both of them and define what it's asking, and then we'll worry about it. So the deal is, what is the log asking? Does anybody know what log base 3 answer 81 is asking. If you read it like that, log base 3, answer 81. What's it asking? Yeah, it asks what power of 3 equals 81. That's all it's asking. What power of 3 generates an 81? And you should be able to answer that one. What power of 3 creates an 81? Fourth. Well, it equals 4. Because 3 to the 4th is 81. What's B asking of us? Log base 2, answer 1/8. Power of 2 equals 1/8. Can anybody answer that one? That's right, Daniel. Daniel says -3. And I'll work that one out for you. Well, the traditional way of doing these things is to say they equal something. Maybe set it equal to an x. You're trying to figure it out, right? And then do the conversion into a logarithm, sorry, an exponential function. You would say 2 to the x equals 1/8. And Daniel was able to do this in his head, and I sometimes question whether writing things down on a piece of paper helps with these or not. But the idea here is to seek a common base of 2, which you did in section 6.3. Seems like 1/8. 2 is a power, sorry, 8 is a power of 2, isn't it? Then 1/8, 1/2 to the third power. And if we have that 2 cubed down low, what happens to its exponent when you shift it up high? What happens to the exponent on 2 cubed when you shift it up high? It's negative. At that point in time, you should see that x is exactly what Daniel said it was, -3, because you have pure equality on the left and the right. I do question whether writing that out helps or not. I think those are the kind of things you know or you don't know. Either way, you still had to know to generate 1/8, you had to cube 2. You had to know that much. All right, any questions so far? Of course, you can also kind of reverse engineer it. Once you realize what it's asking, you can play with the calculator until you figure it out, I reckon. Let's see, find the domain of each logarithmic function. I have probably pulled something out of your notes on here. So if you have a calculator, I want you to press some buttons. And we'll figure out what goes here on our own. I want you to type, you can press the log key, you can press the ln key, nobody cares. Both logarithms. So either log or ln is 0. Did you get ERR? Okay. Now I want you to press the log or the ln key and put any negative number in the world in there. Did you get another ERR? What do you think ERR stands for? Error. Okay, error. Now make up a positive number and type it in. Worked, didn't it? So what did you learn about the domain of a logarithm? Must be positive. That's right. That's the big deal. Domain of a logarithm must be positive. Now, in other words, we have to kind of set up an inequality. There's a relationship between the argument and the value of 0. What must the argument of a logarithm be in relationship to a 0? Greater than. Because you know if you type in 0, it says error. The argument must be greater than 0. That's really all there is to it as far as domain of logarithms are concerned. So if I was looking at example A, what could you tell me about x? What would it have to be? It had to be greater than 2. Have to be. Now, for those of you who want to see in that, you would literally say x minus 2 is greater than 0. You shift your 2 over, and x is going to be greater than 2. How about B? No. What do you know about x plus 3 over x minus 1? What must it be? What must it be? It must be greater than 0. Let's see, we did this section months ago, it seems like. The truth is, you only have to set part of it to be greater than 0, if I remember right. Question is which part? Would it be the top or the bottom? I think we did it with the bottom. The bottom must be greater than 0. It should hold. If x minus 1 is greater than 0, what must x be greater than? 1. And see if that works. You know, plug in like a 2. Plug in a 2, the top would be 5, the bottom would be 1. Isn't that greater than 0? Makes sense to me. And x couldn't be anything less than 1. If it was less than 1, the bottom would become a negative number, wouldn't it? Well, now you're dealing with negative numbers. You just take the denominator and you say it's greater than 0 and you're done with it. You have the same answer. How about C? By the way, those bars really represent absolute value. What's the domain on C? What's absolute value do to any number? Makes it positive. So what's the domain of C? Can't hear you. Still cannot hear you. You're wearing masks. Why do you think I take mine off when I teach? Besides the fact that I don't like masks. So if you throw a negative at that thing, what's it going to turn around and do to it? Okay. So is it going to be able to handle all the negatives? The only thing it wouldn't be able to handle is if you gave it a number that created a what? A 0. So it can handle all the values of x, it can handle all negative values, it can handle all positive values, it just cannot handle what? 0. So that x minus 1, there's only one thing it can't equal. What is it? That's the only thing about this thing we can't fix. That x minus 1 cannot be a 0. Because absolute value makes negatives positive. So I know that x can't be 1. We hadn't done this so far on any of these, but let's write this out as a number. If I can be everything but 1, what can I be? I'm just going to pretend I hear it in mumbling. I can be negative infinity to 1, union with 1 to infinity. Guys, you have to talk up when you're wearing a mask. You have to. Come on, it's Friday, man. Be a little more alive. Let's see here. What are we supposed to do? It says graphing a logarithmic function at its inverse, but then it just talks about finding the domain. Is that the only graphing example I have? Bummer, it is. I'm not too peculiar. I really don't care if you do a lot of this stuff by hand on these. But I want to talk a little bit about the graph. Anyway, something like that does. Let's go ahead and change it so I can say plus 3. In that parentheses, the argument that logarithm, that ln, which I guess is not going to go like I thought it was when we talk about it. In the argument of that logarithm, we have x minus 2. How's it tell us to shift? Shift to the right 2. How about plus 3? Not 3. So when I actually go to graphing, what I'll do is I'll go right 2 and draw in a dashed line, which is actually pretty important. Then I'll go up 3 and draw in another dashed line, which on a logarithm is not all important. That vertical line is a big deal. Because anything to the left of it, if we think about the values of x left of it, like left of 2 is a 1. Would that logarithm enjoy that value? If you threw a positive 1 in that logarithm, what would you be able to do and then move it? Nay, nay. If you threw x equals 1 at that logarithm and typed it in a calculator, what would your calculator freaking tell you? Error. Okay? So that dashed line is a pretty big deal on this. Because I cannot draw anything at all to the left. Alright? I need you to understand that. This thing represents something. Now, I'm not going to walk you through doing this by hand. The truth is, you're not going to anyways. You all know where the ln key is. It's a negative natural log. If you don't, look to the left of the 7 and 4 and you see ln of x minus 2 plus 3. Normally a logarithm looks about like that. This one's got a negative up front, so it's actually going to do something like this. It should be what it looks like. My brain's working right this morning. It should come in from up high and curve down. Fix it. And here's something about the calculator. It doesn't show you everything. It really doesn't. What actually happens is you get ridiculously close to that vertical line and then you start curving down. Do I know what that vertical dashed line is actually representing? Asymptote. Turn off stat lights. The second line goes, you turn off stat lights. Because it's on. Well, as I heard, I was looking for, there's a vertical asymptote. And where is it at? 2. I'm not sure what all happened here before Rona last year, but I feel like we talked about those. What's this thing so made? Due to infinity. How about its range? Positive infinity, negative infinity. Which is backwards. I don't know why I listen to you. Negative infinity to positive infinity, right? Interval notation is always written with the small value first and the large value second. If you want a much better graph, you can always hit second table. You'll have some nice values you can plot, right? It's all on our table. Always has no ability. Now there was something that was in your notes, but I thought it's not, so I guess I need to insert this somewhere. All right, the understood basis. And also change of base that we need to know too. Understood basis would be the first one. The calculator has a log of x button. What's the understood base? Okay. It's really log base 10 of x. It's an understood base. You also have the ln key on the calculator. which also has one of those understood bases. What's the understood base on the ln key? And you know, just look at the keys on your calculator. Look at log x. Look what's in blue above it. What do you see? A 10. And literally, you're not looking at it. Look at the ln key on your calculator. In blue, what do you see? It's telling you what the bases are if you just look at the keypad. It really is. So ln of x is really log base e of x. All it is. Now the other thing we need today is we need to change the base formula. The one that's most often used is this, that a logarithm of base b, argument a, oops, I really don't want to show using log. Is the natural log of a over the natural log of b. That's what I like to use. When you used last year in Algebra 2, although a lot of kids, last year in Algebra 2, I gave you a choice between using natural log of A over natural log of B or log A over log B, and most kids want to use log, but I don't want you using log over log. I want you using ln over ln, and there is a reason for that. So, we need to change a base. And now I think we're in position to actually figure some stuff out. So, what's up next in your little notes should be a section about solving logarithmic equations. Now, example A is going to be ridiculously easy. That is a logarithmic equation. What can you convert it to? An exponential equation. 2 to what power? 2 cubed must equal 2x plus 1. Does anybody need an explanation of that conversion? You're just afraid to ask, just think log is base. When you read that logarithm, it's logarithm base 2, answer 2x plus 1 equal to 3. Equal being e. So if you're going to identify BAE. Now 2 cubed is an 8. Then you got 2 steps. Take away 1, divide by 2, what's your x value? 7/2, correct. Let's see what example B has in store for us. There's a logarithm of base x whose argument is 343 and equals 3. Base is x, the answer is 343, and the exponent is 1. This is one of those you'll have to think about. Now, I know that some of you guys will have to press buttons in the calculator. But your goal is to figure out what x is. It's a number that you cube. You know, if you don't know this, you might go to the calculator and type in like 4 cubed and see what you get. Type in 5 cubed, see what you get. Type in 6 cubed, see what you get. And it's probably the next one. 7, isn't it? X of 7. Here's 7 times 7 times 7. 343 all day long. All right, any issues so far? Of course, we didn't need that change of base yet. We won't need it until we actually have an exponential function given to us, like these. And I really need something else there. Let's see what else in your notes here. I need to make something else up. I'm going to make something else up. Change example A to do that. That's 3 times 4. 4 has an exponent of 2x plus 1. It's supposed to equal 9. and log is base. Now I want you to notice something about that base on the right-hand side of the equation. The base with an exponent is all along, isn't it? Is there anything in front of that base with an exponent? That's a big deal. The base has to be isolated. Now isolate the base. The A may as well literally stand for anything. There could be a freaking smiley face plus a frowny face on the other side. Nobody cares. But the base has to be isolated. All right? So in the example that I created, is our base isolated? You got to isolate the base first. So we're going to divide out. 3. Well, that'll free up the base. And now the base is freed up and isolated. It is now just a simple exponential function, and you can convert an exponential function into a logarithm. The logarithm base what? Log base 4. What's that logarithm's argument? Huh? That's a 3, isn't it? Maybe someone looks I was getting. A 3. What's that equal? X plus 2, X plus 1. Now, on that little page of notes I made up, I gave you what's called change of base. Now, if you just press log on a calculator, you don't have the option of telling it's base 4, do you? No. There is a way to actually pull up change of base on a calculator, but I'm not going to go over that because that's not a good change of base. We're going to rewrite log base 4 of 3 using change of base. How can you rewrite log base 4 of 3 using change of base? Change of base says log base B argument A is a natural log of A over natural log of B. There you go. Natural log of 3 over the natural log of 4. It's 2x plus 1. When you take your higher level test, they like to write things out so that you don't actually use a calculator. So before we go press buttons on the calculator, let's actually solve for x. There's 2 steps. Take away 1 and divide everything by what? 2. If I take away the 1, I'd have the natural log of 3 over the natural log of 4, literally minus 1. When I divide by 2, I just throw all of that over what? 2. That's your x value. Try to write everything out as far as you can without using technology. You really should. So now I'm in that old button pushing mode here. Don't try to do all this at once, because if you do, you'll probably screw it up. We've got natural log of 3 sitting over the natural log of 4. We're going to take 1 away from that. And if I type in what I've got here and press divide by 2, will I get the right answer? No, I'm going to press enter first. Then I'm going to worry about dividing by 2. Logarithms are pretty old. They date back to the 1600s. And it was traditional then, even then, that you gave the decimal out to 4 places. So we've just kind of stuck with that. So the correct answer to this thing would be negative 1.038. 4 decimal places. All right, so that was a good walk down memory lane. You guys are a year older, logarithms ought to be easier. Your brains are getting closer and closer to maturity. Let's see, I don't know that I want to do B or C. I think there's one right here. Yeah, we'll do that one. Solve 2 times e to the 3x equals 6. Kind of like the last one we did. What's the problem with it? Base isn't isolated. What are you going to divide out? 2. So you'll have an e to the 3x now equal to a 3. and convert that thing to a logarithm. Lauren, it would be a logarithm of base what? What's the base? E raised to 3x. What's the base? E. So the logarithm is a base E. That's how it works, kids. You identify the base and it stays the base. That's why when I read these logarithms to you, I say log base, don't I? That's how I need you to read them. Read them the same way in your head. Don't say log 4, 7, because you see a 4 and 7. Say log base 4, 7. What's the log of base E? Again, that's your base, that's your exponent, that's your answer. And the answer of the exponential function is the argument of the logarithm. So what's the argument of a logarithm? 3. That has to equal 3x. Now there's no log base E key on a calculator. Log base E is understood to be what logarithm? Natural log. Rewrite it as ln. Natural log of 3 is 3x. What's the last step to solve for x? Divide by 3. I haven't seen this in years, but I have seen in the past where kids would do like, ooh, 3 over 3, that's 1. Can you do that? No, because that 3 is an argument of the logarithm. It is trapped inside that logarithm. ln3 is a whole different number. Then you go to your calculator, you press buttons, and you're around to what decimal? 4. There's a simple exponential function. Are we at the blood alcohol question yet? We finally make the BAC question. Ah, we did. This is important for some of y'all in a couple of years. Let's see here. Blood alcohol concentration, a measure of the amount of alcohol in a person's bloodstream. BAC of 0.04% means the person has 4 parts of alcohol per 10,000 parts of blood in the body. Blah, blah, blah. There's relative risk. For example, an individual with BAC of 0.02 is 1.4 times likely to have a car accident as an individual who has not been drinking. Relative risk of 0.02% BAC is 1.4. Recent medical research suggests that the relative risk of having an accident while driving a car can be modeled by an equation, R equals E to the kx. We have a nice exponential equation. This is why there is a limit on how much you can drink and what your BAC can be because of the risk. All right, so part A is asking us to find that constant. Now, A says that an individual with a BAC of 0.02%, their risk is 1.4. Find the constant. So what can I replace this R with? R stands for risk, doesn't it? 1.4. E. Don't know the constant, that's the goal. You read the text, X is the percent concentration of blood in the alcohol. So what's X? 0.02. That's a simple thing to solve. Convert it from its exponential form into a logarithm. Now, most of the ones that you've done in their exponential form have the base and the exponent on the left. And I think for a lot of kids, it makes sense to just go ahead and do a quick rewrite. E to the 0.02k equals 1.4. That's the same exact thing. You just flip it around equality. And I think it does make conversion into a logarithm a lot easier. And it does. What would the base of this logarithm be? E, which is understood to be what logarithm? Natural log. What's the argument of that natural log? 1.4. That equals 0.02k. How are you going to solve that constant? Write it out. The constant is the natural log of 1.4 sitting over 0.02. I will do that in the calculator, and I'll probably keep it there using the storage feature. See, I don't want to write that thing down, ever.
I'm just gonna store it next. That way it's there on the need. Because I don't like writing down 6 digit numbers. But it's stored for all eternity until I change the value. Let's see here. Using this value of K, what is the relative risk if the concentration is 0.17%? Pretty drunk. Legal drunk is 0.08. All right, so the risk is E times this K value, which whatever it was, I've got a calculator, right? Times 0.17. Well, that's just plugging numbers. We already have all the numbers too. I got E, it's raised to my X, because I stored it here, remember? Times 0.17. So a person who's at 0.17% BAC is 17.5 times as likely to have an accident than the person who's not from drinking. Seems like there was a dude in Germany about 20 years ago, because I remember reading about it when I was a teenager, who got pulled over and blew like a .43. Passed the field sobriety test. They were like, no, you're drunk. So they actually had to haul him in. He passed the field sobriety test. He was German. He'd been drinking his whole life since he was a kid. And they started making beer and stuff at 6 or 7 years old. It didn't faze him. I mean, he was fine. He was fine to drive. The only reason he got pulled over is because he was speeding. Is there anything else worth doing? Well, here's one that's a relative risk of 100. And I guess we'll just not do it. Anyways, it go on the left. Try and figure that out over the weekend. We'll talk about it Monday when you come back. Seems like Tuesday is ACT day, so you guys will be somewhere else. I'll tell you about that Monday, because I administer that ACT. Some of y'all take it. And go enjoy your weekend, and if you drink, realize now that there is a reason why it's 0.08, plus you're all minors, don't be drinking.
So I can go to the library and work on it and finish up one of my studies. Because this phone won't let me leave my slot there until 11 hours.